dear students, welcome back to my channel. My name is Prachi Sharma. आज से जो हम वीडियो स्टार्ट कर रहे हैं, our target is to finish the whole chemistry syllabus in 4 months. I know, highly ambitious, with all the details, all the questions and everything thoroughly. So it's not gonna be a quick revision, it's gonna be a very thorough one. So अगर आपने अभी तक, आज क्या है 2 अगस्त, अगर आपने अभी तक अपनी केमिस्ट्री की प्रिपरेशन स्टार्ट नहीं करी है या फिर आपने बिट्स एंड पीसेस में करी है एंड यू नॉट कॉन्फिडेंट अबाउट इट, आप आज से शुरू करिए, ठीक है। हर हफ्ते हम 4 वीडियोस अपलोड करेंगे, जिसमें 3 वीडियोस वुड बी थियोरेटिकल और 1 वीडियो होगी आपकी क्वेश्चंस के अराउंड, ठीक है। तो हर हफ्ते आपको क्या करना है, 4 से 5 घंटे, तो 4 घंटे हो गए आपके, मतलब 3 घंटे हो गए आपके ऑलमोस्ट थ्योरी के, और आपका 1 घंटा हो गया जिसमें क्वेश्चंस हैं, तो आप प्रैक्टिस भी करेंगे। सो आपको हर हफ्ते 4 घंटे निकालने हैं एंड आई बिलीव केमिस्ट्री जिन बच्चों की वीक है या उन्हें समझ में नहीं आती है, आप हफ्ते में तो 4 घंटे निकाल ही सकते हैं। अदरवाइज वीकेंड पे आप 2-2 घंटे निकाल लीजिए, सैटरडे एंड संडे को, ठीक है। आप मेरी बात मान के आप इतना करिए, आप 4 महीने दीजिए एंड यू विल बी सो थरो विद द प्रैक्टिस कि आपके क्वेश्चंस भी कंप्लीट होंगे और आपका कॉन्सेप्ट भी आपको समझ में आएगा एंड इन 4 months you'll see a huge difference in yourself, ठीक है स्टूडेंट्स। सो आज हमारा पहला सेशन है इस सीरीज का। आज के सेशन में हम पीरियोडिक टेबल की बेसिक अंडरस्टैंडिंग लेंगे। दैट मीन्स जो भी हमारे मेंडलीव पीरियोडिक टेबल से पहले छोटे पीरियोडिक टेबल्स आए हैं, जो भी क्लासिफिकेशन आई है वो कौन कौन सी थी, उसके बाद जो हमारा मॉडर्न पीरियोडिक टेबल है उसका लेआउट कैसे है, कौन से एलिमेंट्स कहाँ पे प्लेस्ड हैं, उनकी पोजीशन के हिसाब से आप क्या क्या आइडेंटिफाई करा सकते हैं, और अलग अलग पोजीशन पे रखे एलिमेंट्स को हम क्या क्या कहते हैं, मतलब ग्रुप्स, पीरियड्स, और जो ग्रुप की मतलब जो हमारी फैमिलीज हैं एलिमेंट्स की, उनके क्या क्या नाम है, ठीक है स्टूडेंट्स। सो बिल्कुल भी डरने की जरूरत नहीं है केमिस्ट्री से, मैम है आपके साथ एंड वी आर इन दिस टुगेदर। सो लेट्स स्टार्ट इट सेशन। सो periodic table, let's understand the introduction for it. So as the scientists and chemists started discovering so many new elements in the past years, we are talking about ancient years when we were able to identify various elements. At that point in time, a variety of elements were discovered, but it was difficult for chemists and scientists to understand all of that together. And they wanted to create a way that the new generation that's coming in and they have to teach those elements to them, it's easier for them to understand and remember that these are the different elements, this is how their chemical and physical properties work out. So that is the reason why they started working on making different methods in which we can study a set of compounds. So for the a set of elements. So for that, they try to do different groupings and different pairings to understand the common properties, so that instead of understanding all of them together, we can understand them in groups. That okay, this particular group behaves in such a way, and this particular group behaves in certain way. So that is why they came up with different methods. So that is your introduction of periodic table. What is the need of periodic table? The basic requirement is to make sure that you have a better grouping of elements and you have an easier understanding of those elements, and it is easier for you to memorize and do more research on it further. So let's see. The first is elements are pure substances made up of only one type of atoms. I hope that makes sense. Now, the first scientist who was able to give us a grouping was Daubernier. So his triads, that means he gave us grouping of triads. Triads means 3. He was able to give us a grouping of 3 elements together. So that came out to be known as Daubernier's triads. So what he did was, he grouped the pairs in such a way that the atomic weight for the outer 2, so for example you have 3 elements, the atomic weight of outer 2 were sum up, and if you calculate the arithmetic mean, you will get the atomic weight of the center element. So this is how he arranged them. So if we calculate the arithmetic mean, let me use a different color. So if we calculate the arithmetic mean of the corner two elements of the atomic weight, you will end up getting the atomic weight of the center element. So if you try to think about it, so what would happen is you have 40 and 126 as the atomic weight of calcium and beryllium. So if you add that up and divide by 2, you will end up getting 88. And the same thing would happen in the next one. So you have 35 and 127. Add that up and divide by 2, you get 80. Okay, so this was the concept of his grouping. And as the various grouping came into the picture, every grouping had you can say grouping or creating a table. So every one of them had some drawbacks, because of which they were enticed to work on in another grouping. That was the next step. So that is what kept happening over the years, and slowly this grouping improved and improved, and today we have the modern periodic table. So this was one of the earlier ones in which they were able to give us the triads. That was, he was able to group in about 3. What were the drawbacks of this particular one? So he was only able to give us about 2 triads and not more than that. So that was one of the major drawbacks. Second, it was not valid for all the elements. So we were only able to get a couple of triads. Now let's read this through. He grouped the elements in 3, that is triads, with similar properties, such that the atomic weight of the middle element was the arithmetic mean of the outer 2. Then you can learn these 2 examples for it. Let's move ahead to the next one. The next that came out to be known was Newland's law of octaves. So oct means 8, octaves. Okay. So what he did was, so Newland was we can say somebody who was very inspired by music. So he used that knowledge in making grouping for the elements that he was studying. So what he did was, for octaves, what he did was he used the music sa ra ga ma pa, so that you know that you have the I'm not sure what to call that exactly, but when we study music, sa re ga ma pa dha ni sa. So this is the basic grouping, okay, or this is how you start understanding the music, understanding music and learning music. So he used that logic, and he used them, and he said that if I arrange all the elements in increasing order of their atomic mass, after every 7th element, the 8th that comes back, it is repeating the properties of the first element. So that is what he said. So what he meant was, so if we think about it, you have sa, re, ga, ma, pa, dha, ni, and then you have sa again. So sa gets repeated. So 1, 2, 3, 4, 5, 6, 7, and then the 8th element, that is sa, is getting repeated. That means similar to the first one. Okay, so this is what he said. If I arrange all my elements in the increasing order of their atomic mass, then the 8th element is coming back and repeating the similar properties as the first element. So let's read what he said. He said, he observed that when elements are arranged in increasing order of their atomic mass, every 8th element beginning from any element resembles the first element in its physical and chemical properties. Oh, I hope that makes sense to you. Now, what were the drawbacks of this scientist? So the major drawbacks were that first was not all the elements were known to us. So when he was arranging them, some parts were being missed, because not every 8th element was being showing the similar properties at the first one. So there were gaps in between. Then another thing was, just to prove his theory was correct, he actually swapped a couple of elements here and there just to make sure that they were falling in the same concept. So that happened. So there were more drawbacks to his theory, but so therefore it didn't work out. The next is Mendeleev. Now, so what happened in this case? So he gave the first periodic table of elements based on its law. So his law was that properties of elements are the periodic function of their atomic masses. So what he did was, he said that if you arrange your elements in the increasing order of their atomic mass, at certain point the repetition starts. That means an element starts showing similar properties again and again. Now, this was only valid for 63 elements. The second thing was, as per his theory, because he was considering atomic mass, he was not able to add an isotopes in between. Okay, because isotopes were very, they would just separate by small numbers in the atomic mass. So when he tried to add up isotopes, the entire table became really, really big. So because of the introduction of isotopes was mandatory, because he's using atomic mass as the logic, so he was not able to fit in all the elements. Second, it was only valid till 63 elements. So at this point, they realized that if we do use atomic mass as our basic logic or basic concept, we're not really getting anywhere, because every element has a chance of having many isotopes, and it's impossible to put in all these elements in the same table. Okay, so because of this concept, now at this point, we just decided, okay, now let's give up on atomic masses. Let's try to think of something else. Okay, so let's read about it. So this was valid only for 63 elements are known at that time. We did not know more elements than that. Then it did not work for rare earth metals and isotopes. So isotopes, I told you what they are. Rare earth metals, I'll tell you when we start working on the modern periodic table. Okay. Now, next came Henry Moseley. Now this guy was like, okay, for till now, atomic mass is not working for us, so we are gonna give up on it. So he gave up on that and he started working around with atomic number. This guy was smart enough. What he did was that since the last person said that put them in the increasing order of atomic mass, they'll start getting repeated. So he was like, okay, atomic mass is not working. Let me put atomic number in that. So he started working on the atomic number. He simply put them in the increasing order of their atomic number, and he realized they were being repeated. So that was a great achievement for him. So let's read what he said. The physical and chemical properties of elements are the periodic function of their atomic number. So what does this mean? What does periodic function mean? So whenever I say it's a periodic function, that means after a certain point, that particular function gets repeated. Okay. So if something is happening and I say this is a periodic function, this clearly states that after a certain point in time, the entire cycle is going to get repeated. So this is what it means. So this particular person is saying that if I'm arranging all my elements in the increasing order of atomic mass, their physical and chemical properties get repeated. Okay, so this is what he said. Another important thing, students, is when we talk about laws and principles, you cannot change the language. You are supposed to stick with the exact language that the particular scientist has said. So laws and principles are not like definitions that you can just write what you remember or you can just rephrase it. Please do not do that. There's a high chance you would lose marks in board examinations. So stick to the exact wordings of what that particular scientist is telling you. Let's move ahead and let's study about the periodic table. Now, why is atomic number considered a fundamental property of an element? So this is one important question, and I would like you to think about it and send me your answer either in the comment box, or you can also reach out to me on the Telegram channel. Plus, you can also email me at psclasses@icsc@gmail.com. So let's move ahead from here. Now, what happened was, next was Neil Bohr. So he gave an extended form of the modern periodic table. So let's look at the new definition. So periodic table, what is the definition? Now, since it's a definition, you can rephrase it or rewrite it in any form that you want. A tabular arrangement of elements in groups. So when we talk about groups, we're talking about vertical columns and periods which are horizontal rows, highlighting the regular trends in properties of elements is called the periodic table. So students, please don't be scared of this definition. This definition will make sense once you understand this chapter properly. Okay, so let's move ahead. Let's look at the modern periodic table and understand what's happening. So, modern periodic table, this is what it looks like. Now, modern periodic table is a combination of your groups and periods. So, when we talk about groups, so this is what your grouping is. Okay, so 1 group, 2, 3, 4. So, these are your groups. Okay, these are your periods. Okay, like these. Basic, understood? Now, if you look at around here, this you can see there's an arrow marked and you have 2 long tables in the at the bottom. The reason we have them separately is because if you include this F block right in the middle of the periodic table, the entire formation of the table will get disrupted and it will become a very haphazard looking table. That is the only reason. That is for the looks of the table. That is the only reason that it is being mentioned below. Otherwise, they would have easily entered it into the table if they were able to keep it a standard looking table. Since they were not, they just moved it down. Okay, so I hope that makes sense. Do not get scared of this table. This table is very easy. Just focus on the part that is in your syllabus at the moment. You have to learn the first 20 elements. You need to know their atomic numbers by, at the back of your head. You should be aware of all of that. So first 20 in series, in exact sequence. Okay, it should not be like, I know that calcium is in the first 20, I just don't know where it exists. Okay, so you have to learn them in a sequence, and that is just first 20. Okay, other than that, in this whole table, you just need to understand for 10th grade right now, whatever properties that we discuss, you need to understand that if you're going across a period, is that property increasing or decreasing or staying the same? And if you're coming down the group, what is the effect of the property? Okay, so you have to understand the pattern, how that particular property is behaving. So that is what you're supposed to understand for 10th grade. In the exam, they'll give you any part of the periodic table, okay, a small part. A, B, C, D, E elements would be given. And they'll ask you for any particular property, what will be the change in those elements? The elements can be up and down. So you're going down a period, down a group, or it could be left and right. So in that case, you're going across a period. So that is the reason understanding the pattern and variation is important for you right now. Do not spend extra time learning it if you don't understand the variation, because that won't make sense. It's good, and I have seen a lot of students memorize this table very well, and they are very well versed with it. So there is no harm in remembering it for your next year. But first priority should be to understand everything else about this table. Last priority should be to learn beyond 20. Okay, so please focus on that. Let's move ahead. Now, salient features of the modern periodic table. Now we understood that these are groups, have a particular imagination of the periodic table. Initially, I always suggest print out the table and keep a periodic table and put it on the table when you're studying, and whatever reference you have for any definition, please refer to the periodic table. That will slowly build up your imagination for this particular table. So let's start with the first. We're talking about groups. So your imagination should go back and think about groups are the vertical ones. Okay. So there are 18 vertical columns called groups. Each vertical column accommodates elements with the same number of electrons in the outermost shell. This particular point or these type of points you will understand with examples. But I will still give you an idea that when we are coming down the group, the electrons in the outermost shells are the same. Okay. Now when we talk about group 1 is known as alkali metals, except hydrogen, of course. Now why do we call them alkali metals? Because when these particular metals are dissolved in water, they give you strong alkalis. Okay. What are alkalis? Alkalis are bases soluble in water. So these are known as alkali metals. When we talk about group 2, these are alkaline earth metals. When we talk about group 3, in group 3 you have from 3 to 12. So 3, 4, 5, 6, 7 till 12. These are transition elements. When we talk about transition elements, we're talking about the elements in these groups are metals, then they have their two outermost shells incomplete. Okay, so all the elements of these groups are metals and they have their two outermost shells incomplete. Now when we talk about group 13, they are also known as the boron family. When we talk about group 14, they are also known as carbon family. Okay, till group 14, let's come back on the table and let's understand what we are talking about. Okay, let me just erase this a bit for you. Okay, so when we talk about group 1, so except hydrogen, if you talk about group 1, lithium, sodium, potassium, rubidium, so all of these are known as alkali metals. Then this is group 2, these are known as alkali earth metals. Make sure that you pay attention on what elements you have. Then okay, but another thing would be, if you think about first group said that, or like groups generally have the number of electrons in the outermost shell same, right? So for example, let's take lithium. So lithium electronic configuration would be, so it's 3, so that would be 2 1. Then you have sodium, it will be 2 8 1. Then you have potassium, that would be 2 8 8 1. So if you understand the pattern, the number of electrons in the outermost shell is staying as 1. And this is true for all the groups. So you can pick up any group and try it out yourself, that is the outermost shell having same electrons or not. Then when we talk about group 3, 4, 5 till 13, these are transition elements. Okay. Then let's move ahead to the next one. Next you have the boron family. So this is group 13 right here. So this is your, I'm sorry about that. So this is your boron family. Let me mark it like this. So why is it called boron family? It's only called boron family because boron is the first element. The second is your carbon family because carbon is the first element. Then you have the nitrogen family. Can you see carbon family, nitrogen family? Okay. Now let's come back on what information is left. You have carbon family. Then you have oxygen family or chalcogens family, that is ore forming, because oxygen is the basic element when we talk about ores. So you can call it chalcogens. A lot of teachers call it chalcogens. So depends on, it doesn't depend how you pronounce it. You should be able to write it correctly. So that's your chalcogens family. Then you have halogens. So halogen means salt forming. This I always consider the most important group to understand because they ask a lot of questions from these. So let's come back, and then the last is zero group or noble gases, or also known as inert gases. So let's come back here. So this is your oxygen family. Now this is your halogens. Okay, halogen means salt forming. These are really strong non-metals. So if you talk about fluorine, chlorine, bromine, iodine, these are very important for you to remember. Okay, so fluorine, chlorine, bromine, iodine, a lot of questions come around these elements. The last one is called the zero group or the inert gases, or anything that you want to call them, noble gases. Okay, so this is your last group in which all the electronic configuration is completely satisfied. So they are more balanced out and they are not looking for any, they're not unstable in nature. Okay, so let's move ahead further. So this is a basic understanding of the various groups. Now main group elements, that is representative elements, normal elements. So this is group 1, 2, 3, etc. Now valence electrons, if you go like this, the first group had 1 1, second group had 2 2 2, then 3 4 5 6 7. These are the number of electrons in the outermost shell of the groups. So first group will have 1 electron in the outermost shell, second will have 2, third one will have 3. Why is it important for you to remember? Because in the exam, they will not ask you which group it is belonging to. They will directly ask you how many electrons does this particular element will have in the outermost shell. So you should know which group is it falling in, and then how many electrons will it have in the outermost shell. Okay, let's move ahead to the next one, that is periods. So 7 horizontal rows are called periods. So we're talking about horizontal rows. The number of shells present in an atom determine its period. Okay, so when you have the number of shells, they will tell you which period that particular element is belonging to. So I'll give you an example. I'll come back to the table. For now, let's move ahead. Group 3 of the 6th period are known as lanthanides. Group 3 of the 7th period is known as actinides, that is radioactive. Now, if you remember, I marked that at the bottom you have 2 columns given. Those are your lanthanides and actinides. Okay, and they have similar properties as they belong to group 3, but they are shown at the bottom of the periodic table so that they don't distort the shape of the periodic table. So that is what they're talking about in this point. The next is the 3rd period elements, that is sodium, magnesium, aluminium. They are typical elements. When we talk about typical elements, we just mean that they show basic properties of those elements very strongly, and that's it. Next is, a period is determined by the number of shells. A group is determined by the number of electrons in the outermost shell. So this is highly important for you to understand. Okay, so let's come back on the periodic table. I'll tell you. So when we talk about the first period, okay, first period, you have hydrogen. Hydrogen has 1 electron, so your number of shell is just 1. Then when you talk about helium, you have 2 electrons, so your number of shells is again 1 because the electronic configuration is just 2. Then when we move to the second period, so for example, lithium, 3 is the atomic number. So what will be the electronic configuration for lithium? So lithium will be, let me take a few examples, okay. So for example, I have hydrogen, so hydrogen has 1. Then hydrogen, then we have helium. So helium will have also 1. This is number of shells. This is the first period. When I talk about the second period, lithium electronic configuration is 3. So the electronic configuration will come out to be 2, 1. Then after lithium, I have beryllium. So your electronic configuration will come out 2, 2. Okay. Now if you think about it, 2, 2. So this is what is happening here is the number of shells is 2 and 2. That means it is belonging to period 2. Let's move to 3. So period 3, I have sodium, that is 11. Sodium, so that will be 2, 8, 1. 3 shells. And let's take another one, magnesium, 12. So 12 will be 2, 8, 2. How many number of shells? 1, 2, 3. Okay, so number of shells tell you which period that element lies in. And number of electrons in the outermost shell tells you which group it lies in. For example, if you think about this is just 2. So if you think about it, hydrogen, 1 electron in the outermost shell, it belongs to group 1. Then we don't talk about 0 groups like that. Let's talk about lithium. So you have 2, 1, 2, 1. So how many you have in the outermost shell? You have 1. So that means it belongs to the first group. Beryllium, 2, 2. 2 is in the last shell. So it belongs to group 2. For sodium, 1 in the outermost shell, it belongs to group 1. Then same thing for magnesium. You have 2, 8, 8, 2. So you have 2 in the outermost shell, it belongs to second group. Okay. So make sure that you pay a lot of attention on this. That number of shells will tell you the period number. Number of electrons in the outermost shell will tell you the group number. Okay, students, I hope that makes sense. Let's move ahead. So this note is important for you to answer a lot of questions. Now, some important terms. Okay, let's talk about periodicity. So as I told you that when we talk about anything that has a periodic function, that means that particular function is being repeated at a particular period of time. So after a set of time has passed, the entire thing will get repeated. And this particular phenomena in which this periodic function is being repeated is called periodicity. Okay, let's read the definition. The properties that reappear at regular intervals or in which there is a gradual variation at regular intervals are called periodic properties, and the phenomena is called periodicity. Okay, students, what are your keywords here? Your keywords would be regular intervals and after periodic, that is periodic properties, and the phenomena is called periodicity. So keywords would be regular intervals and periodic properties. Let's move to the next one. What is the cause of periodicity? So what happens is, if you think about it, when we talk about the elements in a sequence, after a certain point, similar electronic configuration is repeated. And when we talk about similar electronic configuration, so if you do think about it, all the metals have a tendency to lose electron, because generally they will have 1 or 2 or 3 electrons in the outermost shell. So your outermost shell, that is number of electrons in the outermost shell, helps us understand the chemical property of that element, whether it will behave like a metal, whether it will behave like a non-metal, or what kind of property it will show. How do we know that? That is because of the number of electrons in the outermost shell. Okay, so let's read it. So chemical properties of elements depend upon the number of electrons in their outermost shell. Thus, elements of the same group have similar properties. So what is happening if you pay attention on this? We are arranging the elements in a sequence. As soon as you reach up the 7 mark or the 8 mark, that means 8 electrons in the outermost shell. After that, you get repeated to 1 electron in the outermost shell. So you again come back in the cycle. So this is what is happening. You start with number of valence electrons as 1, 2, 3, 4, 5, 6. Reach up till 8. After 8, you again start a cycle at 1. So this is how the periodic table is designed. Okay, student, and this is the cause of periodicity. This is how the periodic properties are being repeated. Okay, let's move ahead to the next part, that is shells and valency. So, shells and valency, both of them depend upon the orbit. Now, what is the orbit? When we talk about electrons, they are running around the nucleus, and the area that they cover up around the nucleus is known as an orbit. A lot of students ask me, is there an orbit that actually exists that we can see? So the answer is no. There is no orbit that is visible to us. No, there is nothing. We make it like a circle and then we put in the electrons on that, but actually there is no circle that exists. Okay, the electron is moving around the nucleus, and whatever path that covers is your orbit. Okay, but there is no line or no path that is given to the electron. It is the energy because of which the electron is rotating on a similar path. Okay, so electrons revolve around the nucleus in certain definite circular paths called orbits or shell. Okay, so when we talk about the number of shells and we are coming down a group, the number of shells increase. So if you remember, when we were talking about periods and we were going across a period, in that case, the number of shells was the same. I'm sorry. So when we talk about the group, let's take a look at a couple of examples. So I have fluorine, chlorine, bromine, iodine. This is the halogens group. Okay. So let's look at how the number of shells would increase. So the first is fluorine. So when I talk about fluorine, that is easy because that would be just 2, 7. The next would be 2, 8, 7. Then the next would be 2, 8, 18, 7. So what is happening? Your number of electrons in the outermost shell will stay the same, but your number of shells would increase. Okay, so this happens when we are coming down a group. When we are going across a period, the number of shells remain the same. That I already taught you, because the number of shells will be able to tell you what is the period number for that. For example, we talk about lithium. So that will be just 2, 1. Then you have 2, 2. Then you have 2, 3. Then you have 2, 4. So what is happening is your outermost shell electrons are increasing as you're going across a period, but your number of shells are remaining the same. And they are just remaining 2 because you're in the second period. And similarly, when we talk about the third period, you should already know by just looking at the question that if it is the third period, that means you'll have three in total, like means 3 shells in total, and the number of electrons in the outermost shell will keep increasing. Okay, so let's look at that. So first is sodium. So sodium will be 281. Then you have magnesium 282, then 283, then 284. Okay, the reason it is important for you to practice these type of questions is so that they can get fit in your brain so well that by just looking at the question, you have the imagination of the periodic table and you have the imagination of how the trend is working out, and you can directly frame the answers for it. So it's all about practice. Let's move ahead to the next one. So we have valency. Now what is valency? A lot of students get confused with this. Valency and the number of valence electrons are two different things. Okay, so when I talk about valency, valency is the number of electrons an element can donate or accept to attain stability. Okay, so to attain nearest noble gas electronic configuration, to stabilize itself. So that is valency. If, for example, I talk about lithium, so what was the for lithium? I have the example here. So when I talk about lithium, I have 3 electrons. So that means 2, 1. So lithium can donate 1 electron. So if it donates 1 electron, it will become stable. So what is the valency here? Valency is 1. What is the number of valence electrons? That is also 1. Okay. Now when I talk about sodium, that is 281. So it can donate 1 electron and become stable. So what is your valency? 1. What is the number of valence electrons? That is also 1. Okay. Now let me take another example in which your number of valence electrons is higher. Let's pick up something from the periodic table. Let's come back here. Keep taking reference back and forth from the periodic table so that you are used to using the periodic table often. Don't just focus on the theory. Be familiar with this table. So let's talk about fluorine. Okay, so fluorine has the atomic number as 9. Okay, so when I have fluorine, I'll just solve it here. So when I talk about fluorine, so your atomic number is 9. So your electronic configuration will be 2 and 2 and 7. I'm sorry about that. 2 and 7. What is the number of valence electrons? Valence electrons is 7. But what is the valency? Valency means number of electrons donated or accepted. So your valency is 1 because it can accept 1 electron and become stable. So your valency is 1 and your valence electrons is 7. Okay, students, please make sure that you understand that very well. Let's come back on valency now. And I hope the concept is clear to you. So if you think about this, when we go down a group, your valency remains the same because 2, 8, 8, 1. So if you think about it, the number of electrons it will donate would be 1. So whenever you're coming down a period, your valency will remain the same. And when you are going across a period, it first increases and then decreases. So what do I mean by that? Let me take a reference from the periodic table again. Let's come back here. What I'm trying to help you understand is why are they saying first increases then decreases? That is what we are focusing on. So let's take the second period. Okay, I'm talking about the second period. So let me just delete a little bit part so that it is more clear and less haphazard here. Okay, so we are talking about the second period, that is this one. First increases then decreases. I'm focusing on that. So let's talk about lithium. What is the electronic configuration? 2, 1. Right? So what is the valency? Valency is 1. Next I'm talking about beryllium. What is the electronic configuration? 2, 2. What is the valency? 2. Now come on boron. This is 2, 3. Valency is increasing. So first you had the valency. Let me write it here. 2, 1. So valency was 1, then valency was 2. Now valency is 3. It is increasing. Correct? So after 3, what do you have here? 2, 3. This becomes 2, 4. So increases. then decreases. Now let's focus on this. So now you have 7. So 7 would be 2, 5. Number of valence electrons is 5, but what is the valency? Valency is 3, because to reach up 8, it will accept 3 electrons, right? So the valency would be 3. For oxygen, 2, 6. What is the valency? It is 2. Then for fluorine, it is 9. So that means 2, 7. What is the valency? 1. So if you think about it, your valency initially was 1, then 2, then 3, then 4. So first increases till 4, then decreases 3 to 1 again. So first increases, then decreases. This is how valency is affected when we are going across a period. Let's come back on valency. So first increases, then decreases. Okay, students? Let's move ahead. Now, note on valency. Now, I already explained you all the examples. That's fine. Now, valency is the combining capacity, so it is always positive. Okay, because it is combining with something, always positive. Now, let's move on to the last portion for today. That is recap. So, in recap, we'll just quickly go through what we have discussed today. So, the first is elements are arranged in order of increasing atomic number. That is your proton number. Why do we say that? Because when we talk about your electrons number, it is not always the same, because you can also have ions. That is, you can have chlorine minus ion, chlorine positive ion. So, sorry, not chlorine positive, but chlorine minus ions, or you can have sodium positive ion. So, you can have ions. If you talk about change in the number of electrons, then ions are also a part of that. So we don't talk about that. We talk about protons, because the number of protons cannot be changed. Okay. Now let's talk about the next point. The vertical column of an electron, of elements with similar properties are called groups. Then the horizontal rows are called periods. Recurrence in properties due to same number of electrons are seen. Properties of elements depend upon electrons in the valence shell. Okay, because that will tell us whether this particular element will donate for combining. That means will form ionic bond or will form covalent bond. What kind of bond it will form? How will it behave with certain elements? So the number of electrons in the outermost shell tells you all of this information about the element. So gradual change in property is seen with increase in atomic number. Next is reactive metals are in group 1 and group 2. Transition elements are in the middle, and non-metals are in the upper right corner of the periodic table. Now next is transition from metallic to non-metallic character is seen across a period. So this is it, students, for today. Please make sure, so I will be helping you solve all the different kind of questions. So since we are working for a brand new year ahead, so make sure that you're paying attention on all the details, grabbing in all the information, and practicing a lot of questions. So this is it for the session. All right, ICSC वालों, so this is it for today's session. I hope आपको basic understanding table की समझ में आई हो, and you are a little bit more confident about periodic table and a little bit more excited about what is coming next. So in the next session, we'll go ahead and we'll study more about the positions of elements. कहाँ पे क्या position है, उसकी वजह से क्या हमारी properties हैं periodic table की, what all we can study about it. So we'll continue ahead in the next session. For now, please make sure that you like, subscribe and you share the channel with your friends, और उन सबको इस series का part बनाएं, and let's see how well we do. Let's catch up in the next session.